Hello, everybody, and welcome back to a brand new series on this channel. Or channel. Actually, they're both called channels on Twitch and YouTube. This is... Let me just double check I'm not streaming on YouTube. I'm not. Okay, good. This is A to B, or A equals B. The name is still debated, but... Ooh, I accidentally banned someone. That's... Or almost banned them. How do I... Okay, I'll just have to hope I don't accidentally hit that button. It's fine. Maybe I hit their button again. Okay, there we go. What an introduction. Okay. This is A to B. It says on the official... Well, it doesn't say on the official Steam store that it's called A to B. It's on a snapshot on the Steam store. I couldn't find the name anywhere else. I'm gonna call it A to B because it's easier than A equals B. Too long. Like efficiency. Anyway, this is an SOLang. I think I'm high. It says SOLang behind my webcam. Trust it's in the perfect position considering how the screen is laid out. Trust me. Anyway, it's an SOLang, and well, I like programming games, and this was an interesting type of programming game. Caught my eye when I was browsing stuff to do on stream, and you know, I looked at the description, I looked how it's supposed to work, and I thought it was actually quite a powerful language. You could actually do quite a lot with it. So let's see what happens in this game. Maybe in the future I might talk about how cool of a language it is, but for now, let's just get into the basics. Starting with notes. If you're familiar with Zachtronic games, this is very Zachtronic-y. Compiler Principal Course Project Late Submission to Professor. Hello, Professor. I'm a student in your Compiler Principal class. Sorry I missed the deadline for class project submissions. The reason is, according to the class, project's documents... I can't read. A student may choose not to use the given framework and implement a compiler on their own. Then, I decided to take a further step, create a compiler for an original programming language. Since this goal was way more difficult to accomplish than expected, I exceeded the deadline. I hope you can understand. Course report.pdf. Warning, this PDF is actually user manual.pdf with flavor text. Please read it. Right. Let's switch. I already read it while I skimmed it. But let me change screens. I mean, there's nothing incriminating, so... I think. There was nothing there. Maybe one bookmark, but it wasn't the full thing, so I don't think it's an issue. Okay. Let's redo this. Compiler's Principal Course Report. Overview. A equals B is a minimal programming language designed for string handling. It has the advantage of simple syntax, easy to learn, convenient to code, etc., and has a wide range of application prospects. Our project implements a compiler that supports all features of the language. In fact, this document is a game A to B user's manual. This is a work of fiction, blah blah blah. Nobody believes it's the self-aggrandizing description in student project is nothing more than a college culture. Whatever. Instruction set. A equals B, or A to B's instruction set includes string 1 to string 2. Find the leftmost occurrence of string 1 in the string and replace it with string 2. That's it. An A to B program consists of several lines of instructions. Each line must include exactly one equal sign or be a blank line. Execution order, read the input string. Starting by the topmost line, find the first line that can be executed. If found, execute that line and go to step 2. If none is found, return current string as output. Other comments. Okay. Fun. We've got the interface description. Blah, 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 blah. Oh, wow. All my buttons do something. Copy, paste, cut, undo, redo. F7. Okay. All good. By the way, there is a mini game involved with this, which is fun, but okay. Hopefully the microphone is still around. Okay. So with all of that, let's actually go into the first level. Okay. Yeah, I don't think I have to worry. There was nothing there that I didn't want to leak. Okay. Level 1 of 1. A to B. Input, a string of A, B, and C. Output, replace each A with B. So, for instance, ABC to BBC and AABB to BBBB. And I mean, they already gave us the code, so it's not like we have to do anything. So A equals ABC becomes BBC. And then if we run it, there we go. Yeah, so it just takes the string A and replaces it with B. That's exactly what the code describes. Okay, we can race through all of these. there's so many test cases. This is so unnecessary as well. Okay, we did it. Wow. From Professor. You call this a programming language? It kind of is, to be fair. I would call it a programming language. Okay, we actually have to write code this time. A string of A, B, C, replace each letter with uppercase. Okay, so that's very simple. A equals A, B equals B, C equals C. Wow. So hard. Congratulations. Singleton. A string of A, B, C, replace consecutive repeated letters with a single letter. So A, A, B, 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 C, C becomes A, B, C. And then, yeah, okay. Again, it's not a hard one. Double A becomes A, double B becomes B, double C becomes C. I hope we allowed spaces, because... Okay, I like having spaces. Perfect. We could probably make this slightly bigger. I'm gonna make it slightly bigger. I don't see a reason why not. Okay, it worked. Well done. Singleton 2. A string of A, B's, and C's remove consecutive A's. Oh, completely. Okay. We can do that quite easily. I just wonder... So we can do that in about... 4 lines. I can do this in 4 lines, at least. I don't know if we can do it in fewer, but... I'll do it in 4 lines. So, double A becomes capital A. We're going to use capital A as our destroyer. Because it checks the leftmost first, so if there is a string of 3 or more characters, this first A will appear in the leftmost square. Then what we'll do is we do AA equals A, AB equals B. Oh wait, no, that's correct. And then AC equals C. A equals nothing. Okay, there we go. Okay, sorry, that's actually 5. Fortunately. Um, so this should be the last case, so... Oh, actually, if it's a last case, maybe we don't need these 2 lines. Will that work? Let's test it out. Oh, it does work. Okay, so we can actually do A equals nothing. Perfect. Done. Compiler principal course project late submission. By definition, A to B is a programming language, and the document didn't restrict what language I can choose. All right, we're doing a sort. Sort the inputs in alphabetical order. So what we have here is okay. I mean it's not a hard one. We can just do a bubble sort. BA equals AB. BC equal no, that's correct already. CB equals BC, and AC no, it's the other way around. CA equals AC. There we go. Very simple bubble sort. There we go. Done. And now we're doing a comparison. A string A and B. Output the most common letter. Ooh. Okay, this is more interesting. We're given that the number of A's and B's are different. Okay, so if there's an AB, we will delete it. If there's a BA, we will delete it. And then once this program terminates, oh no, once this program passes the 2 lines from here on, only A's or B's. Maybe we use their code. A's or B's. And here, from here on out, we'll write this. So we'll just simplify. If there's multiple, we'll just simplify. Why is this? Okay. Like that. Easy enough. Okay. Oh wait, I forgot to read the last line. I have to point out, your so-called programming language can't even output hello world. It is unable to perform any of the tasks It is unable to perform any of the tasks required by the scoring criteria. Alright. The title says it all. Now, A to B can output hello world. Once again, this will load in, for some reason, in Edge. Why is Edge opening up? Oh, is it because I set the is the default to opening PDFs Edge? That is actually... Oh, it actually is. That's actually disgusting. I do actually have Adobe. Okay, let's just set it to Chrome. Wait, do I actually have a button to show? It's S. Oh, Why do I have it in S? Oh, that's such a bad idea. I hope no one saw this. I have to cut out so much. I'm definitely going to hide the VOD after this. I'm going to disable. I can't believe I have it on S. Oh shit, sorry. Ah! Whatever, I'll deal with this after stream. I just have to remember to not hit any buttons on my keyboard. Anyways. This is such a scuffed stream. Okay, we already did that. String 1 equals return string 2. If string 1 is found, end the program immediately and replace the entire string with string 2. Following characters reserved equals left, right, and that. Bracket must occur at the start of the left or right string in pairs. Return is placed in the middle. Keyword is placed in the middle. Execution order, read the input string starting by the topmost line. Da 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 da. Okay. I think this feels like a spite move. um... Cool. Literally just output hello world. Oh. After everything. There you go. Oops. We should put it the other way around. But it's good. We can actually do nothing equals A. That's a very fun little command. There you go. Definitely not. Yeah, no, it'll work. It terminates. It's just as unsafe as using jump commands, so why not? Or infinite while loops. Done. Easy peasy. Now we can output hello world. From professor, are you trying to make me laugh? It's a hilarious language. A string of A, B, and C. Output, return true if the input contains at least 3 A's. Anywhere? Okay. Um... There are several ways of doing this. Actually, the easiest ways. AB equals A. AC equals A. AAA equals return true. Or true. Okay. Return false. I think that's how it's written. So this will just delete. So if there are characters between two A's, this is just going to delete all the characters between the two A's. make them closer, and then it's going to delete all the characters between to the other A's. Either we're just going to terminate, or either a triple A is found or it's not found. But it's basically just deleting characters between A's so we can find triple A. Done. Easy peasy. Alright. Exactly 3. Return true if the input contains exactly 3 letters, otherwise return false. Oh gosh, we could actually write this in... We could use a lot of lines to write this. I feel like we have to use... Because we don't have a wild card for any character, right? So we have to... Do we have to actually write all cases? I mean, basically, so my idea is just going to be A equals A. Oh wait, that doesn't work. We have to write that last. I think we have to actually write them in reverse order. So the idea is we're going to have A be our indicator that we have the first character. We have at least one character. But we have to put that at the end, basically. A equals B. AB equals B. AC equals B. So B will be how we detected there are these two characters. I just realized there's an easy way of doing this. Actually, we put this in front. So A equals return false. Easy enough. Now it's just going to convert all of the letters into A's. And then AAA equals return true. Otherwise, return false. There you go. I don't know why I had to overcomplicate things. We just change all the characters into the same character because the characters don't actually matter. Yeah, so this will change all the characters to A, to capital A, and then if we have 4 in a row, we know we went too far, and if they have 3 in a row, that's exactly what we want, but we test that after we no longer have any characters to change. And otherwise false. Okay, there we go. Didn't have to overcomplicate it. Remainder. A string of ABCs, divide the input length by 3, output the remainder. So A equal output 0, B output 0, C. Okay. We'll use the same principle, I guess. You could say. We're changing all the characters to A. To one character. A equals A. B equals A. C equals A. A equals 0. And now we need to test all of them. So we need to test AA first. Triple A will delete 3 A's in a row. We don't care. Once we've passed this, now we only have 2 A's. 2 or fewer, I mean. So if there's 2, we return 1. If we're here, that means there are at most 1. So, write that. And if we've reached here, 0. Not 9, 0. There we go. Alright, easy peasy. Okay. Now A to B can help a hello world. So, for the sake of my sense of humor, can you lower your standards a bit? It's still a legitimate programming language. I don't know why. Don't know why they're so uppity about it. A string of ABC. Output return true if the amount of each letter is either an odd value or 0. Input ABC equals true. Input ABAC equals false. Okay. I think I got it. So, yes, so in the first one, each one appears once, so we should set it to true. Here, each one, well, A appears an even number of times, so it's false. Here, A appears 3 times, B and C appear 1 time, so it's true. Okay, got it. Not too bad. There are many ways of doing this. Okay. So the easiest way is to sort them. No, but we have to tell the difference between 0 and an odd. That's the hard part. Okay. So, what we could do, should I just sort them first? Or, okay, hang on. Um, okay, maybe I have a crazy idea. I don't know if it'll work. So the idea is to try to replace double A's with big A, was a capital A, to indicate a double. And the idea is we either check to see if it's like BC. Okay, we can do that. So we can do double A is equal to A, like that. So that'll indicate a double. And then if we do AA, that'll just become A again. So triples will simplify into singles. Wait, actually, there's a simpler way. Okay, well, we will sort them, because I think this is the simplest way. C and CB equals BC. Okay, we'll sort. And then what we'll write is triple A equals A. So we're deleting a pair of evens. And then if we see double A, that means there's an even number of A. So this will, okay. Let me comment it to make it clear. Sort, we'll sort the string here. Delete pairs of A's. If there are at least 3. So if there are at least 3, we'll keep deleting pair. So eventually we'll get to the situation where they're strictly less than 3. So there's either 1, 0, 1, 2. We can only get to 0 if there was no A's to begin with. There's no operation that leaves 0 A's in the string. So, and then if there's 1 A, because we keep deleting even number of A's, we have to have an odd number of A's. So the only way to get 2 A's is if there's an even number. The only way to have 2 A's is if we had an even non-zero number of A's. So, okay, and I will repeat this for B's. Okay, BB. Maybe this is overthinking it, but this is, I think, the easiest way to do it. Well, the easiest way would be to do what I was proposing earlier. Maybe, I don't know. Anyways, 10 lines. Cool. The only, a string of A's, B's, and C's. Output, return true if exactly one letter is different from adjacent letters, otherwise return false. For example, in string BA, BB, CC, first A and first B are different from neighbors. Thus return false. Okay. Okay. I think it's different from both adjacent letters. So in this case, only B is different from both letters. Here, only A is different from both letters. Here, yeah, both A and B. Okay, I see. Okay, I think maybe we do, yeah, so we'll take double A's, double B's, double C's, and turn them into their big character letter. I guess we'll also need AA equals A, BB equals B, CC, oh no, sorry, B lowercase b. And C lowercase c equals C. The capital version, I don't know why I put lowercase. Okay, so after this executes, from here, we return. So from here, basically all of the characters that are next to a character similar to theirs has been joined into one single letter. So what we need to now check, we need to check if more than one ABC exists in the string. So from here on out, we'll delete the A's, the B's, and the C's. Okay. And now we have to go through. Yeah. I think instead of checking all three cases, what we'll do is we'll just write A equals D, B equals D, C equals D, and then we'll check for DD. So we don't have to write A, B, A, C, whatever. Okay. I think this should be fine. So this will just delete all of the ABCs. And then here we will replace. So we'll replace the lowercase with a D, capital D. And if we find two Ds, that means we have two characters. What's this? Oh, we need to return exactly one. Didn't read that. Okay. Okay. All right. So this should return. Okay, so this should return false. It returns true. See? Yeah. Oh. Okay, fair point. Yeah, I forgot about that case. we we swap these two around. So from this point on, they're just two Ds. Okay, there we go. Problem solved. There we go. Send. String of ABCs, return true if C is more than B, and B is more than A. As in the number of B's, and the number of C's. Okay. Wait, that's just the first one, isn't it? I guess it's almost the first one. It's almost the first one, yeah. Okay. Not like the first one, but one of the earlier ones that we check which one's the most. I think we can take something that's kind of inspired by that solution. So, the idea I have is we're just going to replace A, B, B, C's with the respective. So, AB and then BA respectively. we're gonna rewrite this as I've got to remember. So B, yeah, so AB is gonna be that. Or should I sort them out first? Would it make more sense to sort them out first? No, no, I think we do this in one go. Hmm. Maybe maybe that does make sense. Maybe I should sort them first. It's just 3 lines. I'm just trying to think if it's necessary. Because part of the fun of this is to try to find the solution with the least amount of lines. AB. So the idea we're going to substitute. So AB becomes a character, and the idea is we want to get all of the A's to interact with all of the B's, and then we see what happens after that. Because we still need to keep track of the number of B's, right? We need to have that. Yeah, and the idea, I guess, is we want to like step down. We want to take a simple case and we want to simplify it further. Ideally, what that means is we find a way of deleting an A, B, C. Or if an A doesn't exist, then a B, C. Maybe that's it. Hang on. So A, B, C, 0. Otherwise, but how do we force this situation to happen? That's the issue. Because I think we will just end up in an infinite loop if we try. Anything random. Yeah, I think it might be time for sorting again. Okay, we'll sort it. BA equals AB. BC equals. It's so much simpler. Oh, I keep writing. I need to have like the code for sorting just lodged in my brain. There we go. And so what we're now gonna do, we're gonna have a character. AB is gonna be big capital A, and AAB is gonna become A. So all of them are gonna collapse. Now either there was no A to begin with. Wait, no, we have to keep track of the number of A's. This is not gonna work. This is not gonna work. We need to do AB, and then we need to do AB is equal to B capital A. There you go. So it's going to slowly pass itself down the line. And then okay. And then when it does AC, that's when we go to 0. Okay, there we go. So we're just going to run this algorithm, and then we're going to figure out from its output what's going to happen. So the list will be sorted. So now it's sorted. So AB is going to so all of the ABs are going to collapse because we are moving the AB sideways. across the set of B's, all of the B's are going to interact with all of the A's, or as long as there are A's and B's, they're going to interact with each other to form more of these capital A's. So either we either run out of, so is it strictly more? I'm gonna assume it's strictly more. So if after, yeah, so this code will run. All of the A's will interact with all the B's, okay. And then all of these A's are going to interact with all of the C's. Or as many C's as possible. So after this, we're just going to be left with B's. So if there is more A's than B's, there's still going to be an A left after this point. And if there are more B's than A's, there are not going to be any A's. So we can rule out. So we have enough to prove that B is more than A. C is more than B. So every A is going to interact with a C. So if there are no A's left, so wait, so if there is a, wait, I think if there's a B left, we are also in a, no, there has to be a B left in this situation. It's a capital A. If there's any capital A's left, that means we ran out of C's as well. So we also need to do a capital A. Okay. Yeah, so if there's a capital A, that means we have more pairs of A's and B's than we have of C. So which is not possible, which we don't want. So we return false. So now we know there's at least has to be only B's and C's. And so now what we can do is we can do BC equals nothing. And then if there's any B's left after this stage, we return false. And otherwise we return true. Okay. Got it. Got it. Gosh darn it. Right, hang on. I didn't actually prove strict. I didn't do strict equality. That's true. You know what? That's my fault. I didn't do strict equality. So this would be the correct solution for a non-strict version. Which, yeah. Very sad. Okay. Okay, we can at least solve the second case. We can do return true. And then return false. There we go. So that part at least we can solve immediately. We can't do that with the A part. So at this stage, what we need... Okay, I think we have to fix both of these. Hang on. What we need is therefore... Okay, so I think this line's fine. That line's fine. What we need... Actually, I think this line is implied by the rest of the code. If there is only B's and A's, capital A's, that means we can't return true as the C. Okay. So what we need is a way of saying... Oh, I guess it's as simple as writing it. No, wait, that's not simple. Yeah, we need a way of writing no B's. Right? At this stage. Yeah, no, the issue is if we have like the no B closed, then we can't run this part because eventually there was going to be no B's. Ooh. Tough. Okay, we've reconnected. I just need to wait for the frame lag to stop. I think this solution almost works, but not quite. That's very sad. What if we went the other way? So we put the A's at the back. Okay, I have an idea. We only do this stage later. No, but it doesn't work. Hang on. My idea was going to be to return false if we don't detect the B, but we can't do that. That's not how this program works. Alright, this is quite a stumper, I would dare say. Okay, I have an idea. What if we did this in reverse? We compare B and C first. Then we convert all of the... Okay, let me try do it the other way around. Maybe this might work. BC becomes B. BB becomes B... No, the other way around. BB becomes BB. So all of the B's will react with the C. So from this stage, if a B exists, that means we have strictly more B's than C's. Wait, no, that's not it. We need a C to exist. Ah, we end up with the dilemma again. Okay, no, I actually have a dumb idea. It will work, actually. So, I can go all the way back. You know, yeah, let's just do it. I like dumb ideas. Oh god, this is so inefficient. So, this I said was the solution for the non-strict version. We're going to make it into the strict version. It's going to take a bit of time to do that, though. Once we've sorted it, now we're going to convert it to the capital version. How are we going to do that, actually? I suppose we can convert 3 B's, 2 B's into a capital B, and 3 C's into a capital C. Capital B, then we'll do BB equals BB, like that. 3 C's will turn into a capital C, and then CC equals... Wait. There can be 0 A's, right? This might not work either. I mean, there is a way of making this work, but... Oh, so they have to be the other way around. Otherwise, this will definitely won't work. Like that. So beep. So yeah. So this will turn all of these to BBs. We can't do in the issue is we can't say no A's becomes an A. Well, we actually don't. If there is no A's, we don't want it to be an A. Okay. So this will delete. So yeah. No, actually, we can do this. This program will delete 1B from the list. Okay? So the only case we have to but this will only delete 1B from the list if there are at least 2 B's. So if there's 1 B, then we need to check for AB. Because if there's no A's, we're fine. Okay. Similar to here. If there are 2 C's, so if there's 1 C, we're screwed. What we need to check is, I think, if for BBC, I think we need to... No bad thoughts. We need to check for BBC, I think. If there's at least 2 B's, so if... Or lowercase c. If there's one B, we don't care. If there are two B's, then we're screwed for certain, because if we run this, if there's one B, if there's one C, well, okay. Hmm. Maybe I think we only need to do BC. No, no, we have to do BBC. Um, the issue is if there's two B's. If there is one B, we're fine. Are we fine? No, we're not fine if there's only one C. Maybe we can do this might okay, this might actually be more complicated than just trying to fix this code. Okay, AB equals A. Okay. So this will definitely work for unstrict inequality. Maybe these lines shouldn't exist. Or maybe instead of deleting, we create a new character. So maybe like D, like capital B. Maybe that's it. So we don't mind if we delete pairs of threes, right? If we do delete ABC, we don't care. What we care about okay, then after this, so yeah, so after this, hang on. Why is this program is hurting my feelings. I don't know why I said feelings instead of brain. I should have said brain there. Okay, is there a clever way of doing it? Maybe I need to think about it in a different way. Um, maybe I have an idea. We can try a falling block method. It sounds so dumb. Okay, this is the falling block method. Wait. Do I even have to make it complicated? No, let's do it. The falling block method. So at the very end of this code, I'm going to write B equals B, A equals A. Okay. And then we do stuff with the B and A. So basically each time we're going to transform one of these into a B and an A, and then we're going to do stuff to it until we can't do stuff anymore. And specifically, we're going to go leftwards. So we're going to do If AB, we're going to turn that into a capital D. Okay. BB, we're going to turn that into BB. So we're just going to let that pass through. CB, do we want to transform it into anything? Let's transform it in... I don't want to make it too complicated. Let's worry about the other cases first. Okay, so this will fall down. Maybe with A next. Okay. AA, we're gonna make it to AA. BA, we're gonna make it into D. Simple as. And CA, we're just gonna make it into AC. No, maybe we do have to interact with them. Maybe we make it to F. Or maybe make this into E and make this into F. Or maybe we make them into lowercase. So D, D, and F. No, but then we have to specify more characters. Okay, maybe the following block method, like I was thinking, is more complicated than a regular method. Okay. BC. Okay, so we've sorted. There's gotta be a way of changing it. Oh, maybe there is. 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 Maybe it's as simple as that. And I've just been dumb for too long. BC, capital B. Then we're gonna make B. So we're gonna combine BCs. And then we're gonna make B, B, BB into BB. And now if we do AB, we only react with an AB. Then we transform that into a capital A. And then we do AA equals AA. Okay. So now we've paired up ABCs. So now we have pairs of ABCs, it was written as A, pairs of BCs written as B, and then we have individual characters A, B, and C. Now, if this is correct, this must mean there has to be there can't be any A's, there can't be any B's, there has to be at least one capital A and one capital B, I think. Oh, no, we don't care about A's. Never mind, we don't care about A's. Wait, actually, then we can just delete them. In this case, we just delete them. And so in this case, I think what we care about is the existence of a BC. Have I been blindsided? Oh wow, it was just that simple. Oh my goodness. Oh, why am I so dumb? Because these, so yeah, so these B stands for pairs of B's and C's. If we cancel them, that means we have a triple of ABC, which means we can remove them from the equation, and that's just going to be the same thing. Which means that at the end of all of this, there's going to be A's, some capital B's, some lowercase b's, and some C's. If there's an A, um, yeah, so if there is a capital B in this equation, that must mean there is no A's. So we don't have to check for A's. If there is a lowercase b, then this equation is not going to hold. Yeah. If there's a lowercase b, that means there can't be a c, which means we have more c's than b's, so this equation doesn't hold. If there's an equal number of b's, of a and b's, that must mean there is no capital B's left. If there's an equal number of b's and c's, that means we can't have a c left. So this is the only... Okay. Got it. Oh my goodness. Pain. Wait, what was the first one I was referring to? Or was it this one? I don't remember. Oh, this was the case, but there's only 2 letters. I see. That's why. Got it. I confused myself a bit as well. Okay. Return the most common letter from 3 characters. Okay. There's no tie for the most. Good to know. Are we sorting again? Is that gonna be what we're gonna do? Maybe. I think that's probably the easiest, right? Sort it first and... Maybe not. I think there's a funner way of doing it. AB equals C, capital C, BA equals capital C. Is this a fun way? A, capital B, C. Ah, this will not work. Yeah, this program will not work, I think. Yeah, okay. The proposed program actually will not work. There's ways for the program to lock, which I have to make sure it doesn't. Maybe we just sort them. we just take the simple way out. A, B, C. Bum. We have an A. So my idea was to transform pairs of ABs into C's, capital C's, meaning that this is like a negative C. And then the idea was going to try to be to reorganize them. It could work actually. No, wait, this could work. Okay, but I think we should sort them. Wait, sort them. Or maybe we don't need to sort them. So AB equals capital C. Okay, so that's like a negative C. AC equals negative B. BA equals capital C. BC BC equals capital A. CA equals capital B. CB equals capital A. And then we just need to sort them, basically. I guess the question is whether all of them will cancel. That's the only thing I'm worried about. So what we then need is we then need AA equals nothing. AA equals nothing. Okay, that's actually that's gonna be more annoying. I mean, it probably works, but it's gonna be annoying to deal with. I think we're just gonna sort them. A equals AC. CB equals BC. And now we just do the same thing as we did before, basically, right? AB equals capital B. BB equals BB. And then BC equals nothing. And AC equals nothing. And then A return A, B equals return B, C equals return C. No, that's not going to work. Okay, now it's going to work. So what this is going to do is that it's going to take... I guess we could replace this with C if we want to be consistent with the negative aspect. We only have one negative letter, and it's going to be C. So we're going to sort them. Then AB is going to turn into a negative C. We're going to transfer the negative C's to the other side of the B's. And then hang on, this is the wrong character. Then we make the negatives and C's interact. Boom. The number of negative C's that could produce is equal to the minimum of A and B. So if the C's is smaller, if the C's are smaller than the A's and the B's, then we're going to end up with a bunch of A's and negative C's, which is fine. We're fine with that. The point is, after this stage, we should only have two characters left. Yes, because the number of negative C's that produce is the minimum of A and B. So either A is the smallest. So if C is not the smallest, so if C is the smallest, then we'll end up with a bunch of. We'll end up with a minimum. Actually, no. Scratch all of that. The minimum number of negative C's is equal to the minimum to the minimum of the number of A's or the minimum number of B's. Let's say it's A. So we're going to end up with B's. Or yeah, let's go with no. Okay, yeah, let's go with that. So we're going to end up with a bunch of B's. Okay, gonna wait for the connection to stabilize. Okay, we're gonna end up with a number of B's, a number of negative C's, or a number of C's. We end up with a bunch of negative c's if the c's is the smallest, in which case b is the most. Okay. If we end up with a bunch of c's, then we can just cancel. We've removed an equal number of a, b's, and c's, so we just cancel the b's and c's until we end up with the majority. If b is the smallest, we do the same thing. We either end up with a's and a bunch of negative c's, in which case a is the biggest, or we end up with a bunch of a's and a bunch of c's, in which case we cancel and see which one is the biggest. If they're equal, they both cancel to get a bunch of negative c's, which will then react with the c to produce c. Okay. And if c, okay, yeah, this should work. Neat. Least. Return the least common letter. Is this easier or harder? I don't know. What we could do is copy the previous code and then just transform every A into a capital B and capital C. That's the easiest way of doing it. Because that'll get a solution automatically. We could do that. It won't be too hard. Is that a direct way of doing it? Let's do that. I can't think of a direct way of doing it. That wouldn't take lots of lines. How would I even do it? I guess so. In this case, if we have a bunch of negative c's, then that must mean yes, c is the least because it's negative. Otherwise, if there is a c, okay, let me just copy over this part. Hopefully, I can copy it over. There we go. So now we're gonna do the same thing. We'll have a's, the number of a's, the number of b's, and the number of negative c's. Or the number of c's. But we're just we're adjusting it so that we're adjusting it so one of them is 0 basically. Okay. In this case, if there is a c, so okay, let's do this. If there is a negative c after this stage, that means c is the least, so we return c. If there is a c, if we pass this stage, that must mean that c is not the smallest, so there is a c. And that means that whichever character is the least is not on the screen. So we return the other character. So this code is even shorter than the previous one, which is very neat. Oh, it actually tells you the least amount. Oh. Wait, what? Oh, right. It tells you what the least amount is. That is cool. Okay, no, let's actually do that. I assume it's 3A's becomes what becomes 2A's and then 2A's becomes 0. That would make sense. There we go. Done. Okay. 1, 4, 6, 5. Okay, we can do this one in a shorter amount of time. Why not? We just reuse the letter A. There we go. Okay, and this one. Once again, why don't we just reuse the letter A? So we have to do one fewer conversion. Okay, this one. We can probably save up on a letter. Uh. Yeah, I have to pay attention to that restriction then if I want to do it. Okay, CC equals C, capital A equals A, capital B equals B. Oh right, yes, that's this program. In 13 lines. Um, kills D D D D. Yeah, so the issue. So we can't just transform A into a random character. We have to actually transform into separate characters. So we can't remove a character from there. Um, um, actually, this is kind of challenging. Okay. Could that work? I'm thinking of a possible solution, but it does seem kind of complicated. So the idea is going to be AB is going to be DB. So let me write over. AA is going to be, wait, that's going to be, no, that's already going to be 9 cases. Then we have to finish the entire code in 4 lines. I don't know if that's possible. Let's try it anyways. AA is going to become SA. AB is going to become DB. So we're just going to write D for difference and whatever character for the same. So after all this, we're going to have a string of S's and D's and then a final character which we don't care about. AC equals DC. BA equals DA. BB equals SB. BC equals SC. CA equals DA. Oh, sorry. This should be D. CB equals DB. CC equals SC. Then what we need to do is we need to find, we delete, no, so we need to find, okay, so DDDD equals no, this doesn't work either. Because the issue is we need to find, so we now have a string of S's and D's, and we have to check if there is 2 consecutive D's. No, there's exactly 1 pair of consecutive D's, which I feel like it's as hard as the initial problem, which is why I don't think it's the correct solution. Maybe we do DD S equals DD. DD equals return false. DD is true. No, that's not going to work either, because it's going to block. If it's DD, SD, SDD, this is going to return true, which shouldn't, which should return false. Yeah. If I could do like DD equals R first, maybe. And then we can do RS equals R. R return false. R return true, and then return false. Right, that's ideally. So this would work, and it's 1 fewer line. Oh, it's not even, it doesn't even work. DS, right? Oh, right, the first letter. Okay, so this is definitely just not gonna work. Um, I forgot that the first letter technically should also count, so if it's the first letter is a D, but we just can't check for that. A weird program. I just spilled all over myself. For no reason. Gosh darn. Um, Let me see if I can remove a code from this line. A couple lines from this code. Because it is quite close. It's quite close. Um, okay, we can at least remove one line, I guess. We could do... No, we can't remove. It has to be different. That's why I had to make it different. Um, yeah, we can't just delete stuff from the list, otherwise it would be very useful. Um, ooh. A equals A, yeah. 2 lines. How do I remove 2 lines? Man, this is hard. Ugh. Is there a different way of doing this? Is that it? Maybe there is. Um, hang on, I have an idea. We'll use inspiration from from the first thing, from the Singleton thing. CCC equals C. CC equals C is empty. Well, no, wait, that definitely will not work. Yeah, this definitely will not work. It will. My idea was to do a left to right scan. So the issue is this one, this code. Maybe if I ran it in a different order, but I think that would still not quite work. Oops. I don't think this works either. So this reduces all lists to just 2 characters. Maybe it does. Okay, so this first takes any triplets and reduces that down to 2 characters. So we have pairs of couples and then singles. Then this will delete a pair. The issue is that might join a single with a double. Right, that's the issue. And if I put this first, then it might take a triple into a single, and I don't want that either. And if I go back to this solution, I end up with, if I tried this, but I just end up with the same solution, right? So I might as well just use the solution. Too tough. Tough. And there's no way to just add a character to start. That's the other unfortunate issue. We have to start from the first empty space. Double A equals A, double B equals B. Yeah, so for this one, if we deleted B and well, I guess we didn't delete. That's the issue. If we could just delete the first character, then we would be grand. Um, okay, maybe there is a way of saving space here. So we have a bunch of uppercase. Um, we added, hang on. What if we did this in a slightly different order? That won't work because we might end up deleting two B's and two B's like that, joining them together. Okay. Yeah, I'm stumped. I don't actually know how to convert this into 13 lines. Um, Man, there must be a way. I guess this line is probably the wasteful one, but Um, is there a way maybe of deleting characters? Hang on, maybe there's a way. This is probably not going to work. AB equals A DB. BA equals BDA. AC equals ADC. CA equals CDA. BA BC, right? BC equals BDC, and CB equals CBD. DB. I guess this technically uses the same amount of lines. What did I write at B? It should be D. And I guess the point is like DAD equals S, DBD equals S, DCD equals S, and then we delete everything. But I guess it's the same solution, isn't it? Yeah, then we just delete everything. A equals 0. A equals nothing. B equals nothing. C equals nothing. D equals nothing. It uses even more lines. But maybe, hang on, maybe there's a way. Maybe there's a way. Maybe this solution works? Who knows? Maybe. Okay. Should I just delete the first A? No, because then it won't match BA, right? Hmm. Okay, I think I'm just not gonna waste time anymore. It's the only one actually, and this is. It's the only one though. It's the only one. Damn you! In this, I mean, it makes sense to try and solve it in this session. Damn you! Or maybe I leave it to the next session. I mean, I think I already streamed for more than 2 hours. So, and considering that I'm basically just spending the entire time just staring at the screen, it's probably not the healthiest way of dealing with this problem. Yeah, it just requires like a completely different approach, basically. I think this approach is maybe this is the correct approach, but then maybe this part is incorrect. I feel like this is very efficient because then we have 6 different types of characters, and all we need to do is just try to find all of the ones we need. Is it that we don't need to do this part? Maybe? Um, yeah, because A. I don't know. Maybe there's something here. Maybe. Maybe, okay, hang on. No, it doesn't work. We need a way of inserting a character to start, but we can't do that. Not with this. We can't do it with this program. That's the issue. We can't just insert random characters. Or can we? Probably not. Um, like ideally, I would like to match the first. Check to see if the first 2 characters is equal, and then discard if not. Yeah, writing down all the cases is also going to take too long. Because there is a lot of them. Wait! Oh my goodness, there is a way. There is a way. I keep pressing Control V instead of Control X or B. Wait, no, that is correct. There's Control C and Control V. Wait, what? There you go. It's working. We can assign them the same character because we don't care about. Now A to B can output hello world. No. We did it! We did it. Okay, and that's where we're gonna stop for today. Thank you very much for joining me. I hope you had a good day. And I hope you have I hope you come back and enjoy the next episode of this beautiful, beautiful game. It's really fun. It is, as one person who commented on the Steam page, enjoyable if you like Comsci homework. But yeah. Thank you very much for joining me. And have a good one. Bye-bye.